way cheaper. Yeah.
So a farmer in Saskatchewan, this is on page 41, this is question number 15. And you'll get a question like this on your quiz as well, so I wanted to go over this. Wants to estimate the value of a new combine after several years of use. A new combine is worth $370,000. This is an old textbook. I think combines are almost at $1 million now with inflation. They're getting pretty expensive. I don't know if anybody drives a combine on the way to work or school. But just like every vehicle, like if you buy a new car, that car 2, 3, 4 years down the road is not worth the same amount. I would love it if I could sell my car for the same amount that it was worth new. That would be so amazing. But that doesn't usually happen. I guess there's some like specialty collector cars that go up in value, but most ones that we just regularly drive, they depreciate. So this combine depreciates in value by about 10% each year. This will make a geometric sequence. Estimate the value of a combine at the end of each of the first 5 years. So end of year value. Now the tricky thing in this one is how you think about the wording in the question. It starts with 370,000, so its value at 370,000 is actually like year zero. Like it's not the end of year one, it's at the beginning of year one. At the end of year one, it's going to go down by 10%. Well, 10% of 370,000 is 37,000, and so you would have to subtract 37,000. Or, in the same way that we did a shortcut for taxes, does it make sense? And I'm going to go to my calculator here. That if you're taking 10% off of something, you are left with 90% of its value. So instead of timesing by 0.1, which is 10%, I can multiply by 0.9 and just see how much is left. And I get the value right away. And that value is actually my R value. So I could now take this one to find the next year, times it by 0.9, 10% off, 90% left. Again, so this is end of year 1, end of year 2, end of year 3, end of year 4, end of year 5. So if I was making my chart, end of year 1 was 333,000. End of year 2, 3, 4, and 5. And notice how on my calculator I just typed back and forth. Once I figure out that R value, and I can write it in here, I notice that my R value, and I'm multiplying by 0.9 because 10% is being taken off. Next year, 299,700. Year 3. $269,730. And we can write down year 4 and year 5 as well. $242,757. And finally, $218,481.30. What type of sequence did you do? Well, because we're always multiplying by 0.9, that makes this geometric. So when something's depreciating and getting less by 10%, you'd be multiplying by 0.9. If it was depreciating by 15%, you'd be multiplying by 0.85, because 85% would remain. This is somewhat helpful if you go into a store and there's a sale on, and they say 30% off. In your head, you can multiply the price by 0.7 and get a quick estimate how much you're going to pay. It's $20, 0.7 times 20, $14. You already can get the value directly instead of having to do 30% first and subtract. Same thing when taxes are added. If we add 12% tax, we multiply by 1.12. Right now, United States has a bunch of tariffs, so if someone in the United States wants to buy something from Canada, they pay the normal Canadian price, but then they get an added 35% tax on top of that, depending on the item. So the tariffs are like an added tax. Okay. Predict the value of the combine at the end of 10 years. So I could just keep going on my chart, and I could get to the end of 10 years and find out what that value is. Or I could use my formula for geometric sequences, and this is one of the reasons I wanted to do this question with you, is if I make my term 1 $370,000. Which term am I looking for if I want to find the end of 10 years?
11.
I'm going to want to find term 11. Number one mistake that happens on this question, and the textbook has done it as well, is sometimes the answer keys are wrong. It's really easy to just say, oh, I'll find term 10. But term 10 would be the end of 9 years, not the end of 10 years. So then this becomes 0.9, 11 minus 1 would be 10. I type this into my calculator exactly as I see it. $370,000 times by 0.9 to the exponent of 10. $129,011. Does it say? I guess I could put cents as well. Usually they'll say to round it. Dollars usually round to the nearest cents or to the nearest dollar, so I just decided on rounding to the nearest dollar here. $129,011. Is that what the answer? Did they get it right? They did get it right. I think on the online program, sometimes they've got it wrong. I'm not. So just wanted to go through that common mistake of thinking term 10 instead of term 11. Also introduce you to the idea of depreciation and how those percentages work.